All right, and 3-6 is 3-5 are the same things, except these are word problems, and we got to figure out what the equations are going to be, okay? So y'all, 3.6 is solving applied problems. And in math, when you see the word applied, we're talking about word problems, okay? So in 3-6, the first two questions are just getting you into being able to translate a sentence. So I'm going to start out with doing a couple of those. Now, let me let some in real quick. All righty. All right, so this first example, they want me to translate the statement. So they're giving us the sum of three numbers is 50. And y'all, like I said, all they want us to do is translate this into a mathematical expression. Now this one will have four answers you'll choose out of, but I'll use my three numbers. I'm going to use X, Y, and Z to represent them. And then remember, sum, when you see sum, that means you're going to add. When you see is the equals. So the sum of three numbers, I know they're adding, so that's going to be a X plus a Y plus a Z. Remember, is means equals, so I'll put my equals. And then the only thing on the right side is that 50. Okay, y'all, so here we go. The sum of three numbers, we don't know the numbers, is 50. And that's it on that one. So they're just getting you ready to translate these sentences they're going to give us on the last three problems we do, okay? So here's another one. We're going to translate the statement. All right, so this one says the first number is 50 more than the sum of the other two numbers. And if you notice, once again, their keywords on here is my equals again. More means you're adding, and sum means addition. So I don't know this first number. I'm going to call that X. So X is equals, and then it's 50 more than the sum of the other two numbers. So the other two numbers are being added. So that'll be Y plus Z. And y'all, then we got 50 more, which means that's going to be another addition of 50. Now, here's the thing on this problem. In the answers, we need all the variables on one side equal to a number, sort of like we were setting up these equations on Tuesday night. So we need to, on this one, we need to get the variables all on the left side. So that means this Y and Z from the right side, we got to move. So since they're positive, we're going to subtract a y from both sides, and we're going to subtract a z from both sides. So I'm going to move these both at the same time by subtracting them both. So over here, we don't have any like terms at all. So I'm going to put them in alphabetical order. I'm going to bring down my x minus my y minus my z. When y'all look on the right side, the y's cancel, the z's cancel. All that's left on the right side is our 50. So this is how you want to pick the answer in MathLab. You want all the variables on one side equal to your number, okay? So these two problems were just to get you good at figuring out these sentences they're doing. So let's actually solve a system of equations. Now there's three of these. I'm going to work one of these out all the way by hand because all three of them are going to be similar when we set them up. I will work out one of these by hand, and then all of them I'll actually do on the calculator because more people told me they're using the calculator more. So this first one I'm going to work all the way out, like I said. So the trick is coming up with our three equations. So y'all, the first one, in a triangle ABC, the measure of angle B, so the measure of angle B is 30 degrees more than 3 times the measure of angle A. So there's me one equation. They're telling me that this angle B is 30 more than 3 times angle A. Then they tell us the measure of angle C is 60 degrees more than the measure of angle A. So that's going to give me my second equation based off of this sentence. But y'all, that's all they gave me. Next, they say, hey, find the measure of each angle. So basically, we got this triangle sitting here. We don't know the measure of all these angles. Here's A, B, and C. But they want me to find the measure of all the three of the angles. But y'all, here's the thing on this problem. Let's figure out what our first equation is going to be. So this one says the measure of angle B is, so that's going to be B equals 30 more than 3 times angle A. So that's going to be 3 times angle A plus my 30. So the measure of angle B is 30 more than 3 times angle A. Now the second sentence, the measure of angle C, well, that's going to be C equals 60 more than angle A. So y'all, that'll just be A plus 60. Now remember, when I work this, I need all the variables on one side equal to the numbers. So we're going to have to move this 3A to the other side and this A to the other side when we start working this, okay? So let me start with my B equals 3A plus 30. So all we're doing is getting this one in the right order. So y'all, you're going to have to come in and subtract 3a from both sides. Remember, these are not like terms, so I'm going to put them in alphabetical order. So this one gives me negative 3a plus the b. On the right side, the a's cancel. All that's left is a 30. So the first equation is now in the right order. So now we need to do the same thing to this equation. So that was c equals a plus 60. So you ought to move that a over. I'm just going to subtract that from both sides. Once again, I don't have like terms, so that'll be negative a plus c on the left side. Well, on the right side, the a's cancel. All that's left is our 60. So y'all look here, we got two equations. Negative 3a plus a b. Now I'm going to leave space where the c would go. So the c would go here. And then that first equation equals 30. So I'm just bringing these two equations and making up my system now. This one was a negative a. There's no b here, but it has a plus c, and this equaled 60. So remember, I'm making my columns for my a's, my b's, and my c's equal to my answers over here. So y'all, here's the question of the day. What could be my third equation? So let me ask you this. What do y'all know about the three angles of a triangle? What do we know about these three angles?
They're equal to 180 degrees.
They're equal to 180 degrees. Good job. So my third equation will be A plus B plus C equals 180 degrees. I now have a system of three variables with three equations. So y'all, we can now solve that. Now let me show you a trick on this one. What I do on these kind of equations, you got this one up here is missing a C. So I could eliminate the C from these two equations, and automatically this will become the second equation. Or I could eliminate, this one don't have a B, so I could eliminate the B from the first and the third. And then this would automatically become its second equation. So what I'm going to do on this, I'm going to eliminate the B's. Okay. So I'm going to eliminate B on my equations. All right. So to start eliminating that B, I'm going to add this first equation. So let me write my equations 1, 2, and 3. So to eliminate a B, I'm going to have to change the sign of one of these B's because they're both positive. So what I'm going to do is multiply this first equation by negative 1. So I'm going to multiply first equation by a negative 1 and add to equation 3. So we're going to come in and multiply this whole row by a negative 1. That negative 1 is changing all the signs. Negative times negative makes that a positive 3a. Negative times positive makes that a negative b. There's no c here. But remember, a negative times 30 makes that a negative 30. So I multiplied row 1 by negative 1. Now I'm bringing down row 3, which was an A plus a B plus a C equaled 180. So my goal was to eliminate the b's, and y'all look at that. Them b's will cancel now when I add this. So 3 and 1 give me 4a. I got a plus c down here. And that's going to equal 180 negative 30. Give me a 150. So y'all, here's what I like about this. I now have this 4a plus c equals 150. Look here, the equation I didn't use a while ago. It has an a and a c only in it. So that becomes the second equation. So bring down the negative a plus the c equals 60. So now we got to think about this. I got to eliminate one of these two variables. I can either try for the a's or I can try for the c. So y'all think what I'm going to do on this one is eliminate the c's because they'll be easier. So I'm going to eliminate the c. So to eliminate the c, so let's call this equation 4 and equation 5. So to eliminate c, I'm going to multiply equation 5 by a -1. And then that +1 and -1 will cancel. So multiply 5 by a -1. All right, y'all, so I'm going to have to pull my paper over now. Oh, let me pull it up to here. So I didn't change row 4, so that's going to be a 4a plus c equaled 150. I am changing row 5 by multiplying by a -1. So negative times negative makes that a +a. Negative times positive makes that a -c. And then a negative times 60 gives me a -60. So let's see. Look here, the c's will now cancel like we wanted. So I'm going to end up with 4 plus 1, which is 5a. That's going to equal this 150 minus 60, which is 90. Y'all, we're down to one variable, so now we can divide both sides by 5. So that cancels, giving me a 1a. 90 divided by 5 is 18. Now, I know angle A is 18. So look here. I'm going to put an 18 in for the A on the first equation. I'm going to put an 18 in for that A, multiply by 3, add 30. That'll give me B. Then I can put the 18 in for this A, add 60, and that'll give me C, okay? So y'all, here we go. Let me flip my paper here. All right, so back substituting. I'm going to do B equals 3 times A, which was 18, plus 30. And remember, these are the original two equations that I was using in the beginning. In the other one, it'll be C equals A plus 60. Well, that'll just be 18 plus 60. So I'm going to work both these out. That'll give me B and C. So here, 3 times 18 is
54.
54. So I'm going to have B equals 54 plus 30. All right, what are we getting there? 54 plus 30. Oh, we're getting what, 84? All right, y'all, let me let one in real quick.
Yeah, 84.
All right, then my other one, C equaled 18 plus 60. So that's what, 60, 70, 78?
Yeah.
So now I know my angles. So in MATLAB, it'll have angle A, angle B, angle C. So remember, A was 18, B was 84, and then C was 78. So now I'm going to go back to where I had my 3 equations right here. And I'm going to show you how to put these into the calculator. Now, I'm going to put a -3 for the A. I'll put a 1 for the B. On this first equation, what are we putting for the C? Because there's no C there at all.
0.
We're going to put a 0 there. So in our calculator, anywhere we got missing variables, we got to put a C in there for a placeholder, okay? All righty, y'all, so let me screen to the calculator. All righty, so remember, go to matrix by hitting second x -1, and then go edit, because we're going to put in our matrix. So I'm going to hit enter. So I still got 3x4s. So enter, enter. And then let's put in our numbers. I had -3 for the A, enter. 1 for the B, enter. 0 for the C, enter. And that equaled 30 on that row. All right, enter that. Second row, I had a -1 for the A, because that was a -A. 0 for the B on that row. And then 1 for the C. And then that row equaled 60. And y'all, this last row is the one y'all gave me. 1 plus 1, well, 1A plus 1B plus 1C all equaled 180. So A plus 1B plus 1C equaled 180, and enter. So once all your numbers are in, the highlight goes back up to the top left of the square there. All right, so now the matrix is in there. I'm going to hit second mode to quit the screen. So that matrix is now stored in our calculator. So now we got to go do the math to it. So second x -1, I'm going to arrow right to math, and then arrow down RREF. And enter. All right, y'all. Then for the third time, second x -1 for the matrix stuff. But this time we just hit enter because we already edited and everything. So hit enter. It brings A on the screen. So y'all, we're looking for the right column. So there we go. A, B, C order. A is 18. B is 84. C is 78. So I ain't gonna lie, the calculator's a little quicker than us doing them by hand. Question on that one. So y'all, that'll be the trick on these, is getting them set up and then solving them. So this one will be like number 4. That was like your number 3. This is number 4. Now, this one says the sum of 3 numbers is 56. So there's my first sentence. Then they say the difference of the largest and smallest is 51. And then the third sentence they gave us, the sum of the 2 smaller numbers is 13. So they gave me 3 sentences this time. So now they say, find the numbers. Now, this one, MathLab always, on the answers, it'll say the numbers from largest to smallest are, and then we put them in order, okay? So these, they do ask for a specific order when you put them in the answer blank. All right, so I need to translate these into my sentences. The sum of 3 numbers is 56. Now, since I got 3 numbers and they're talking about small numbers, large numbers, I'm going to let the X column be my largest number. The Y column will be my middle number. And then the Z column will be for my small numbers. Because I want to put these in order when I'm making these sentences up. So y'all, first off, the sum of the 3 numbers, X plus Y plus Z, all equaled 56. But y'all, now they start throwing a little bit of a curveball because this next sentence says the difference of the largest number and the smallest number is 51. So I know the right side is 51. What would y'all put on the left side for the difference of the largest and the smallest?
X minus Z.
X minus Z.
X, good job, minus my Z, which means on the calculator, we're putting a big 0 here, okay? All right, then y'all, here's the last one. The sum of the 2 smaller numbers is 13. Well, I know that's 13. What's going over here to represent the sum of your 2 smaller numbers?
Y plus Z.
Y plus Z, there you go. Which means here I would put another 0, okay? Now, I'm not working this in by hand, but I'm going to do it on calculator. But if I was working it by hand, since there's no X here, I would either get rid of these X's, or since this one don't have a Y in it, get rid of the Y's. Either way, it'll work out just like the one I did with the triangle, okay? So we're going to spit this on the calculator. So for our answer, the numbers from largest to smallest are blank, blank, and blank. So y'all, let's go punch it in and see what we get. I'm gonna clear everything out real quick. All righty, so we're going to our matrix, second x negative 1, edit, and enter. It's still a 3 by 4. All of these today are going to be 3 by 4, okay? So I had 1, 1, 1. And they equaled 56. And enter. All right, let me see what my chat's saying. Oh, my chat done lit it up. Let's see if we get that. So on chat, Nancy said 43, 21, and negative 8. So we're about to see. So I got a 1 here. 0 on that row for the Y. Negative 1 for that Z. And that equaled 51. And that's actually pretty quick on that. So good job. So this last row has a 0 for the X, enter. 1 Y. 1 Z. And that equaled 13. And enter. All right, y'all. So I'm going to quit the screen, second mode. All right, now let's go get second x negative 1. Go to math. arrow down, RREF, and then go to second, X -1 for the matrix, and just hit enter. All right, so let's see. I'm hoping for a 43, 21, and a -8, it looks like. Bam, and there you go. And what's nice, since I made my columns large, middle, small, they're giving me in the right order. So the largest is the 43, then the 21, then the -8. All right, y'all. So yeah, that's how you put them in Math Lab. So now let me show you how to set up this last one. I won't work it by hand. It's going to be just like the triangle one and this one. You're going to have stuff missing on it like this one did. So this will be like y'all's number 5. That's a little long, so here we go. So by eating 1 egg, 1 cupcake, and 1 slice of pizza, a child consumes 301 milligrams cholesterol. Y'all, then it says, I'm sort of writing uphill, it looks like. Next it says, if the child eats 3 cupcakes and 4 slices of pizza, they take in 90, the child takes in 90 milligrams of cholesterol. And then finally, by eating 2 eggs, and 1 cupcake, the child consumes 566 milligrams of cholesterol. So you know what they want to know, right? They gave us 3 types of foods, all these amounts of cholesterol. So they want to know how much cholesterol is in each item. So y'all, once again, I'm going to sort of set up my columns like I did here with the large, middle, small. I'm going to do an egg column, a cupcake column, and a pizza column. So my eggs will be my X's. Cupcakes will be my Y. Pizza will be my Z. And then they'll all equal their amounts of cholesterol here. So the first sentence, 1 egg, 1 cupcake, 1 pizza. That'll be 1X plus 1Y plus 1Z. And y'all, that one equaled 301. So look at your second sentence. 3 cupcakes. Well, cupcakes is the Y, so that's going to be 3Y. 4 pizza. Well, pizza is my Z. So 4Z. If they ate 3 cupcakes, 4 slices of pizza, they took in 90 milligrams. And then finally, 2 eggs. So that'll be 2 X's. 1 cupcake. That'll be 1 Y. That equaled 566 milligrams. So now enter answer blank. They'll say the egg equals, the cupcake equals, and then the pizza equals. So I don't know much about cholesterol. So I wonder who has the most cholesterol, the egg, the cupcake, or the pizza? All right, y'all. So in the calculator, 111, 301, 034, 90, 210, 566. All right, come on, clear everything out. All right, go get my matrix. Go to edit and enter. So I still got a 3x4. All right, this is one enter, one enter, one enter, and 301. And enter. All right, next row I had 0 enter, 3 enter, 4 enter for the 4 pizza, and that equaled 90, we said. All right, y'all, last row was 2 eggs, 1 cupcake, 0 pizza, and that equaled 566. Enter. All right, who's got me an answer? Okay, so I got Samantha, 278. Woo, them eggs are pretty high compared to that cupcake and that pizza. All right, y'all, so let's check Samantha and see what we get. Come on, quit the screen. Go back in x-1 for the matrix, math, arrow down RREF, enter, and then go get that matrix. Second, x-1, enter. All right, so we're hoping for, looks like a 278, 18, and a 9. Ooh, I got a 274. Check your calculator again. Typo, okay, I was about to say, because, yeah, you probably had a 274, 18, and 9 like mine. Good job. Good job. Those are not too bad when y'all get good on that calculator, okay? All right, y'all, so that was 3.6. Now we're going to get into 3.7. And I'm actually going to do some of the ones you'll see in 3.7 support first. Because that's mostly what 3.7 in college algebra is doing anyway. So this will be the support for 3.7 real quick. And y'all, I don't know how long it's been since y'all did any. We're going to be graphing inequalities. And remember, inequalities are less than or equals, greater than or equals. Okay? Inequalities are less than and greater than stuff. So when we graph these, there's a few things we got to do to the graphs. So let me show you the steps on graphing. So the first thing we look at is what kind of line am I going to draw? These are going to be straight line graphs, okay? Straight lines. But it depends on what kind of line I draw. Because if it's a solid line, anything on the line will make the inequality true. If it's a dashed line, then that means the points on the line do not make it true. That's why we use a dashed, okay? So to determine what kind of line I use, listen, if it's greater than or equals or less than or equals. If it has equals in it, we're going to use a solid line. Okay. If it's a greater than or a less than, if it has no equals on it, then I will use a dashed line. Now, y'all, here's the thing. In MATLAB, when you graph a line, you're going to graph that line tool first. Remember the line tool? But you got it. By default, it's on a solid line. So if you got a dash line you're going to use, there's a place in MATLAB where you click on the dash line and it makes your lines dashed for you. So greater than equal, less than equal, solid line. Greater than, less than, dotted line. Now, these are inequalities. That means they got more than one answer. They can have a whole infinite many answers. So what we do is we shade the region where the answers are located. So on a graph, we're going to be shading. So if it is greater than and equals or greater than, we're going to shade above the line. Now in MATLAB, the shade, when you do the shading part, MATLAB's going to have a paint can, and you drag the paint can over to either the top or below the line and click it, and it'll shade it in for you, okay? So if it's greater than and it's shaded above the line, then that means the less than stuff, the less than and equal or less than, they're going to shade below the line. Okay. So when we get to the inequalities, this is what we're going to do. Now, the first two in support are not inequalities. They just want us to graph lines, okay? But there's two special lines they want us to graph. So number one for support says something like, hey, graph y equals -1. Well, y'all, when you got y equal to any number, I don't care what this number is, but if y equals that numbers, this is going to be a horizontal line. It's going to be a horizontal line left to right. And when it's y equals -1, it don't matter what x's you pick. All y values must be -1. So if you make you a table and you're going to pick 2 points to draw your line, remember, all y values must be -1. So you got to put a -1 for both of the y values. Now, I can pick any numbers I want for the x's. So for me, I'm going to keep them small and use a 0 and a 1. It don't matter what x's you pick, like I said, but remember, every y value has to be -1. All right, so let's graph this. X, Y, I'll go out about 5. All right, so let me get my 2 points first. 0, -1. 0 on the X, down 1. And then this point was 1, -1. So right 1, down 1. And like I said, any point you pick, that y value will be -1. So it's going to make a horizontal line right there. Now remember, this is not an inequality. So in MATLAB, you just plot the 2 points. It'll draw your line and be done, okay? So first special line is a horizontal line. Next, they want you to graph. And this is just getting you ready for a couple problems in college algebra, okay? So this one, they said, hey, graph x equals 3. Well, y'all, if the y equals the numbers are horizontal, then the x equals a number are going to be vertical lines. And guess what? It don't matter what the y values are. All the x values will be 3. So all x values must be 3. So we can make our little table over here, x and y. And we know that every one of these x's is going to be a 3. So I can pick any 2 numbers from a y, and guess what? I'm going easy. I'm going to pick a 0 and 1 again, okay? So let's draw this graph. You know, it's small again, so I'm going 5. All righty, so let's put our points. 3, 0 will be right 3 and 0 for the y. And then I had 3, 1. That'll be right 3, up 1. Once you plot the second point in MATLAB, it's going to come in and draw you a vertical line. All right, so like I said, the first 2 are just getting you good at drawing these special lines here, okay? So now, let's start some of these inequalities I just gave you the rules for. All righty, so y'all, this next one, I think it's like number 3 or so. This time we're going to graph y is greater than 5x. Well, y'all, this could have 1,000 answers, infinitely many answers, because there's a lot of numbers that could be greater than this 5 times whatever number. So that's why we shade these to represent all the answers. Now, I'm just going to find me 2 points. And I'll show you how you can shade on them calculators, okay? It'll shade these graphs for us. Now, remember, this one has 2 variables in it, so I don't get the straight lines like I did a while ago, vertical and horizontal. So this one, I physically got to pick me a couple numbers for the x's. I'm going to have to plug them in and see what the y value is. So if we plug a 0 in, 0 times 5 is 0. If I plug a 1 in, 1 times 5 is 5. I got 2 points, so let's see what we're going to do. We're going to make our x and y axis. I think I can still go to 5. And you know, like I said, I'm going to show y'all this one on the calculator also. It will shade for us. If you got the 84 CE version, it'll shade in color for you. And I actually think the little calculator 84 from the phone app store does them in color if you want. So first of all, my first point, 0, 0. Well, y'all, that's sitting right there in my origin. Second point is 1, 5. So right 1, up 5. So right 1, up 5 puts me right here. So let me ask y'all this. Do y'all think I'm going to draw that with a solid line or a dashed line? And remember, to determine that, I'm looking at that little inequality right there.
Dash line.
Dash line. So let me dash this. Now remember on MATLAB for this one, you would have to choose the dash line because it's going to be on solid by default, okay? All righty. Am I going to shade it above the line or below? So remember for greater.
Noah?
Okay, I see it. Oh, one of y'all's right. One of y'all got me wrong. So remember, greater than is going to shade above the line. So above the line would be all this over here. Okay. And all, so anything I shaded will make that true. Anything that's not shaded makes this false if you plug the numbers in. Okay. So let's see. Here's a -1 I shaded right here. That's a -1 for the X that I shaded. If I put a -1 in there, I get -5. Is 0 greater than -5? That's true. So this shaded area is making it true. Okay. So now on the calculator, I'm going to show y'all how to shade a graph. So let me clear all this off. So I'm going to go to y equals, and I'm going to put in 5x. Now, here's the thing. All these, you can use the calculator that have it solved for the y, okay? You can't do the one with the x because it don't have a x equals. It only has y equals, okay? But y'all watch what I do to shade this. I'm going to arrow left of the y1 over here. Where that blue box is blinking, I'm going to hit enter. Now, this is a CE calculator. And then I'll show y'all on the old school calculator. So mine's going to shade blue. So I'm going to arrow down where it says line. And let me show you. To shade above, y'all see this triangle here? It's bigger on the top part. That and shades above. When I hit arrow right again, this one shades below that's bigger on the bottom. So I'm going to go back to the one that shades above. And I'm going to go down and tell it okay. Y'all, now when I hit graph, remember that graph we had, we shaded to the left side? Watch this. There you go. Shaded on the left side, okay? Also, if you wanted points to use, you can use second graph to get the table. So I used 0, 0 was my point and 1, 5 from Walgo. So once you graph it, you can get all the points from here to put in MATLAB, okay? All righty, y'all. So I just wanted to show y'all a little bit about your support. It'll have 2 more pretty much like these to graph. So what I need to get into is our 3-7 college algebra. And it'll have more examples doing the graphing. So 3.7 is systems of linear inequalities. All right, y'all. So let me see here. So the first 4 are basically going to be like those problems you just did in support. except they got one that's a little tricky that I'm going to do here. So let me see this first one. Let me get my notes here. So the first one, they want us to graph y is greater than x minus 3. Now, you got one in support that'll be like this. That's why I didn't do it and this one both. So, now, y'all, you can go really quick on the calculator. Go to y1, put in x minus 3. This is greater than, so you're going to use a triangle that's bigger above when you shade, okay? But I'm going to do this one on the calculator on the older 84 plus. All right, y'all, I need two x values. I'm going to use 0 and 1. So 0 minus 3 will give me a negative 3 for that y. When I put my 1 in, 1 minus 3 gives me a negative 2. So I got my 2 points. So let me draw my graph out. To 5 again. All righty, y'all. So let's see. My 2 points were 0, negative 3. So that'd be right here. And then 1, negative 2. So right 1, down 2. Now, y'all, I will say on the calculator, the only thing you can't do on the calculator is do the dashed line and solid line. It's always going to use a solid line on it, okay? All right, so this is greater than, there's no equals. So we're doing a dashed line again. Greater than shades above the line. So if I'm shading above the line, I'm coming in here. And shading that whole left side of that line, okay? All right, y'all, then we're done.
Okay.
So now, let me do this one on the calculator. Now, remember, I'm going to switch my calculator to the 84 plus. So if you got these older calculators, I'm going to show you how to use it, okay? So let me go to y equals and clear this. All right, so I'm on y equals, I had what? X minus 3. So x minus 3. Now, on the older calculators, you don't get all the color options. So I'm going to arrow left on it and just hit enter. It don't bring up the other box and all that. So the 84s, I'll just hit enter until I got the triangle that was bigger on top like this one. So I got it highlighted now. So let me hit graph. So remember, we shaded the left side, and there you go. Okay, so really the only difference between the calculators is that the CE will do these in color. And y'all, once again, if you want to see your table, second graph. So there's my 0, negative 3. I had 1, negative 2. Any 2 points, plot them and be done. So really almost like your first section we did in 2-1, graphing lines, other than we're shading this stuff now, okay? Now, here's one of the harder ones in this homework. We're going to graph 2x minus 5y is less than or equal to a negative 15. Y'all look here. We need to solve that for the y. Once we solve that for y, then we can find our numbers, plug it in the calculator or whatever. but you got to solve this for the y. So I'm going to tell you what, that 2x is moving to the other side. So you're going to subtract that 2x from both sides to move in. Now, I'm going to keep this side x's first and then the numbers. That y equals mx plus b stuff. So those cancel. I got negative 5y less than or equal. So remember, they're not like terms. So I'm just going to put my x's first and then my number. So now you got a negative 5y here. We need to make that a positive 1. So we'll divide everybody by that negative 5. So this negative 2 will divide by the negative 5 for my x's. And then that minus 15 will divide by negative 5. Remember, multiplication and division distribute over everything. What are y'all doing with this thing? What are y'all doing with that less than or equal?
I gonna bring it down.
Well, I'm going to bring it down, but I need to do one thing to it.
Flip it.
Flip.
I'm going to switch it. There you go. Remember, on an inequality, if you divide by a negative number, y'all, you better reverse the order of that inequality. And I'm going to write that over here. Reverse the inequality since dividing by a negative. Now, if this was a positive 5 and I divided by a positive 5, I wouldn't have reversed it. I would have left it alone. It's only on those negatives that you're flipping them. So y'all, negative 5 divided by negative 5 makes that a 1y. Greater than or equal. And all these negatives are making everything positive on the right side. So a negative 2 over negative 5. I can't divide the numbers, but the negatives cancel, making that a 2/5 x. And then this negative divided by negative is what a positive 15 divided by 5 is a 3. So now we have our equation. And this equation is the one, if you put it in calculator or MATLAB, we have a greater than. Although the original problem started out with a less than, we got to treat this now as a greater than, okay? All right, y'all, so let me get my graph ready because I'm about to get my 2 points here. So let's see, I'm going to go out 5 to start. I always use 0. So I will use 0 on this one. So if I put a 0 in for the x, 0 times 2/5 is a big 0. And 0 plus 3 gives me a 3. So let's see if y'all remember back from our first week or two. When I did these fraction equations, what was my second x going to be? And remember, I hate adding fractions, okay? So if you want to get rid of this fraction, this x needs to match that denominator. So my second x will be a 5. Because y'all, if you use a 1 here, 1 times 2/5 is 2/5. 2/5 plus 3, well, you're going to have to find a common denominator and all that fun stuff. So watch when I put my 5 in. I'm going to have 2/5 times 5 plus 3. Well, y'all, them 5s cancel, making a 1. 1 times 2 is 2. 2 plus 3 gives me 5. I want to plot nice whole numbers. I don't want to plot anything that looks like a fraction, okay? All right, y'all. So we got 0, 3. So 0 up 3. I got 5, 5. Right 5, up 5. All righty. So the first question would be solid or dashed? All right, I'm trying to find I'm not seeing nothing on my. So what are y'all saying?
Solid.
All right, it's definitely solid. Remember, if it's got equals on it, it's definitely solid. Now remember, when you do the shading, go by the final equation. That final equation is greater than, so you're going to come above the line and shade it. Okay. All right, like I said, if you do it on the calculator, just go to Y1, plug this in, arrow left, use the triangle above that's bigger, hit graph, and be done, okay? All righty, y'all. So, oh, where'd my paper go here? I had the two special lines that we did in support. And the reason we drew them in support, because we're about to graph them in 3-6. So this next example says graph. And this one had graph x greater than 2. Now remember, I don't need no work on that one. Since x is greater than 2, it's like the graph we had a while ago where x equal 2. We know that every one of these x values will be 2. Okay. And once again, it don't matter what y values you pick. So I'm going to use my old friends, 0 and 1. So I sort of like graphing these straight lines because there's no work. I mean, it's telling you, okay? So let's go out 5. Alrighty, y'all. So 2, 0 is right 2. Stay on the line. 2, 1 will be right 2, up 1. So I can tell it's going to be my vertical line like I wanted. Is it going to be solid or dashed? And y'all got a greater than.
It's gonna be solid.
So let me get my chat back up. So dash, there you go. So what side was on? Right there. So here's the question. That's a vertical line. It don't have an up or a below. So here's the question. This is on the x-axis. Which way are you going to shade? Which way is going to be greater, left or right? So check it out. X is greater than 2, right? So are these x's greater than 2 or are these x's greater than 2?
Left.
Oh, I see y'all.
Right.
Y'all saying, y'all look like my chat. Right. There you go. To the right. 5 greater than 2. 4 greater than 2. 3 greater than 2. All these x values are greater than 2. And y'all, I'll tell you a trick. The x's, if you got x less than or greater than a number, it points the way you shade. You see how that's pointing to the right? So that's telling me to shade the right side of that line, okay? All right, let's try this one. Graph y greater than or equal to a positive. Oh, that was a negative 2, my bad. So y greater than or equal to a negative 2. Well, not much work on this one, because we know that every one of these y values is going to be negative 2. So once again, you can pick any x's you want. So I'm going to stick with my 0 and 1. Now, since this one is a y, you can do this one on the calculator. You can graph y is greater than or equal to negative 2 on the calculator, okay? Just punch a negative 2 in y1, go left, greater than triangle, and be done. Ooh, I think the worst part about graphing is drawing all these graphs, you know? All righty, so 0, negative 2, 0, go down to negative 2. 1, negative 2, go right and down 2. So there's my horizontal line again. It's got equals in it, so it's going to be solid. And it is greater than, are you shading above or below?
If it's
Oh,
greater than, don't you shade above?
above, there you go. So everything above that solid horizontal line. Okay. All right, y'all. So you do these 4 problems in 3-6 so that we can do the one problem that deals with the system of equations. So there's only one that deals with a system of equations that are inequalities. Now, here's the thing on this. When solving a system of inequalities, the solution is the double shaded region. So that's going to be where 2 shades overlap each other, okay? That is the only solution that'll satisfy both equations. So we're looking for double shaded regions on these. So they're going to say graph, and this is like number 5, graph the system of inequalities. And y'all, you can graph a system of inequalities on the calculator, so I'll show you how to do this one both ways, calculator and hand. First equation, y greater than or equal to x plus 4. Second equation, y is less than or equal to 1 minus x. So y'all, I'll do these by hand. I'm going to set up an x and y table for each one of these lines. So I'll do the first one here, and then that one. I'll pick my numbers for this one. Once I got my numbers, we're going to come over here and graph both lines on our graph. So I think I should be good with 5 again. But I'm going to leave some space in case I need to go bigger. So let me get 2 points for the first one. I'm going to use both these graphs. I'm just going to use zeros and ones for my x's because there's no fractions to worry about. So 0 plus 4 is 4. Put a 1 in. 1 plus 4 is 5. So there's my first line. So I had 0, 4. And then right 1, up 5. First line is solid. Actually, both of these are solid because of the equals. So I'm going to come in here and make that a solid line. It's greater than, so I'm going to shade above that line. So we're shading above that line. I'll use blue for that one. All righty, y'all. So let's see. For the second one, if I put a 0 in, 1 minus 0 is 1. If I put a 1 in for the x, 1 minus 1 is 0. So y'all, we got to point at 0, up 1, and then right 1 and 0. That line is also solid coming through here. But notice, this is less than, so I got a shade below that line. All right, y'all. So I'm going to show you how to give you the answers. Tell me if you're going to pick you're going to pick C right here, look, because it's the double shaded section. Is the left triangle here? Well, look here. The only double shaded section that's got the blue and the yellow in it is that left section. This is not a solution for both of them, and the yellow is not a solution for both. The only solution that satisfies both of these lines is this little triangle section right here. So y'all, let's do that on the calculator real quick. All righty. So I'm going to go to my calculator. Go to y equals and clear all this off. So for y1, I had x plus 4. So I'm going to go to x plus 4. I'm going to arrow all the way left until I get the triangle above. So enter, enter. So I got the triangle above. Now I'm going to come down to y2, and I'm going to put in my 1 minus x. That one was less than, so I'm going to arrow left and hit enter till I got the less than triangle. So there's greater than, there's less than. So I've got both of these now put in. I'm going to hit graph. And remember, you're looking for the double shaded area. And y'all a little quicker than we did by hand, but you can tell that it's that left triangular section. Now watch this. If you graph them on the calculator, if you hit second table, it gives you x values in the first column. Well, this y1 is the x values for that graph, -2, 2, -1, 3, 0, 4. This y2 is the y values for the second line using the -2, 3, -1, 2. So you can plot them in there and get all the points to graph both lines if you had to, okay? Now, this one, MathLab's just going to give you A, B, C, D, and pick one of the 4 pictures. But yeah, not bad by hand if you use these calculators. And so there was our graph, the double shadeds, pretty dark here, okay? All right, y'all notice Either way, okay? So, questions on that? All right, y'all. So here's the thing. That is all the material for my first test. So when we come in next week, Tuesday night, we're reviewing for test 1. And my review will be just like y'all's quiz review, okay? Remember, the test review counts as your quiz grade. Mine will be the same as y'all's except for the numbers. Now, what's nice is you can do the review quiz as many times as you want. Okay? It'll keep the best score. Okay, so here's the second part of this. The test. I'll open the test next week. The test will be due Sunday night of next week, but you only get one chance. Okay?
Okay.
So that's why you want to do the review as many times as you can, y'all. The review is the same 20 questions as my test will be. It's just going to change the numbers. That's it. So if you go on that review and you're wanting an A, if you can make a 90 or better on that review, you'll make a 90 or better on my test. Okay? The people who do the worst on this test are the ones that don't really do the review. Okay? Remember, they're in the same order. They're the same questions. Hell, some of the times you might even get the same numbers. It only generates so many questions, so remember, as many times as you want on the review, but your test is only once. And remember, the test has to be due by the due date. You cannot work past the due dates on the test, okay?
Okay.
All righty, y'all. So that's most of my spiel for today. So I'll quit recording this so I can get the video sent out later.